Cold, silent, perfectly built for the kill, the great white shark has ruled the oceans for over 15 million years. With rows of serrated teeth, an extraordinary sense of smell, and a body designed for explosive speed, it sits at the very top of the marine food chain. It is feared, misunderstood, and endlessly portrayed as a monster. Because of that fear, great white sharks have been hunted, culled, and blamed for attacks that are statistically rare but emotionally unforgettable, which makes them an easy target. So what if one day, the ocean's most iconic apex predator simply vanished? What if the great white shark disappeared completely? What if the great white shark did not decline slowly, but disappeared entirely within a short span of time? Not pushed to the brink, not reduced in numbers, but removed from the ocean as if it had never existed. No more great whites patrolling coastal waters. No juveniles growing into apex predators. No silent regulators at the top of the food web. This is not a fantasy driven by fear or science fiction. It is a controlled hypothetical built on a very real concern. Great white sharks are already classified as vulnerable, facing pressure from overfishing, bycatch, habitat loss, and decades of targeted killing fueled by misunderstanding. Scientists have long warned that apex predators do not need to go extinct to cause damage. They only need to disappear enough. To understand what would truly happen if great white sharks vanish, we first need to understand what role they play right now. Not as monsters, but as regulators, selectors, and stabilizers of ocean life. Because the consequences of their absence would not begin with chaos. They would begin quietly, in places most humans never look. The great white shark is not the largest predator in the ocean, but it is one of the most influential. Adult individuals can reach over 6 meters in length, weigh more than 2 tons, and cruise vast territories with remarkable efficiency. Their power does not come from constant hunting, but from precision. A single successful ambush can sustain a great white for days, sometimes weeks. Biologically, great whites are apex predators. They have no natural enemies once fully grown. Their role is not to wipe out prey populations, but to regulate them. By targeting weak, injured, or slow individuals, they improve the genetic health of prey species such as seals, sea lions, and large fish. Just as importantly, their mere presence alters behavior. Marine mammals do not linger in one place for too long. Fish schools shift routes. Entire ecosystems move differently because a great white might be nearby. This effect is known as a top-down trophic influence. When an apex predator is present, it keeps the layers below it in balance. When it disappears, that balance begins to unravel. Studies from regions where large sharks have declined show clear patterns. Mid-level predators increase rapidly. Their prey populations collapse. Habitats such as seagrass beds and coral-associated systems suffer as grazing and feeding pressures spiral out of control. Great white sharks are also long-lived and slow to reproduce. Females take many years to mature and give birth to relatively few pups. This makes their populations extremely sensitive to human pressure. Once removed, they do not recover quickly, if they recover at all. Understanding this scientific foundation is critical, because when the great white shark disappears, the ocean does not lose a villain. It loses a stabilizing force that has quietly shaped marine life for millions of years. The first change would not look dramatic. In fact, it would feel almost invisible. With great white sharks gone, coastal waters would appear calmer. There would be no massive silhouettes moving beneath the surface, no sudden dispersal of seals near shorelines. To humans, this absence would feel like relief, but to the ocean, It would feel like the removal of gravity. The earliest impact would begin with marine mammals, particularly seals and sea lions. Great white sharks are one of the few predators capable of controlling their populations. Without that pressure, seal numbers would rise rapidly. At first, this seems harmless, even positive. More seals mean healthier populations, right? But unchecked growth comes at a cost. As seal colonies expand, their feeding ranges widen. Fish stocks that once sustained balanced ecosystems would be consumed faster than they can recover. This leads to the second layer of consequences, the explosion of mid-level predators. Species such as smaller sharks, rays, and large predatory fish would thrive without competition or threat from great whites. These animals do not hunt selectively. They consume enormous quantities of smaller fish, shellfish, and invertebrates. In regions where shark populations have collapsed in the past, scientists have observed dramatic declines in scallops, clams, and reef-associated species shortly afterward. The pattern repeats itself with unsettling consistency. As prey species vanish, habitats begin to degrade. Seagrass meadows, which depend on balanced grazing, are stripped bare. Coral reef systems lose key species that keep algae in check. Once algae dominates, reefs suffocate. What was once a complex living structure turns into a brittle, dying landscape. This is not a slow process measured in centuries. In some documented cases, it unfolds within a single decade. The third layer reaches humans directly. Fisheries collapse as commercially valuable species decline. Coastal communities that depend on fishing suffer economically, not because the ocean has become empty, but because it has become unbalanced. Fishermen are forced to travel farther, spend more, and catch less. Tourism shifts as once rich marine environments lose their biodiversity. Ironically, the removal of a predator meant to make the ocean safer ends up making livelihoods more fragile. The final and most unsettling consequence is behavioral. Without apex predators enforcing natural boundaries, ecosystems lose their structure. Species no longer adapt to risk. They overconsume, overcrowd, and destabilize their own environments. The ocean becomes louder, busier, and biologically poorer at the same time. Productivity drops. Resilience disappears. At the same time, mid-level predators dominate the food web. Rays decimate shellfish beds. Smaller sharks strip reefs of key species. Coral systems fail at scale, removing natural storm barriers and leaving coastlines exposed. Erosion accelerates. Flooding worsens. What began as a biological imbalance transforms into a geographic and economic crisis. Fishing communities collapse first. Then entire coastal economies follow. Food prices rise as seafood becomes unpredictable. Governments impose restrictions, emergency quotas, and artificial controls that mimic what nature once did effortlessly. But these measures come too late and cost too much. The most disturbing part is this: the ocean is still full of life, but it is the wrong kind of life, in the wrong proportions, doing the wrong things. Diversity shrinks. Stability vanishes. Recovery becomes a question not of years, but generations. If the great white shark were truly gone, humans would attempt to replace what nature once handled silently. New regulations would emerge first. Fishing limits would tighten. Protected zones would expand. Entire coastlines would be monitored and managed not for conservation, but for damage control. What was once a self-regulating system would become a network of rules, patrols, and emergency responses. Technology would follow. Governments and research institutions would invest in artificial population controls, tagging and relocating marine mammals, and even culling mid-level predators to slow ecological collapse. None of these solutions would be elegant, all would be expensive, and none would fully replicate the selective pressure once imposed by a living apex predator. In reality, the complete disappearance of the great white shark is unlikely to happen all at once. But history shows that ecosystems do not require total extinction to break. Significant declines are enough. Many of the patterns described here are not hypothetical. They have already occurred in regions where large shark populations have been heavily reduced. The great white shark cannot be easily replaced because it is the product of millions of years of evolution. Its slow reproduction, wide-ranging behavior, and selective hunting are not flaws. They are precisely what make it effective as a stabilizer of marine ecosystems. No technology, policy, or artificial control can truly replicate that role. What makes this scenario unsettling is how easily it could happen without anyone noticing at first. No explosions, no sudden silence. Just a slow unraveling of a system that once held itself together. And if the loss of a single predator can destabilize an entire ocean, then one question remains. What if the next species to disappear is not feared at all, but something we depend on even more? That is a story for another What If.